for bigger size facilities, and in order to increase the overall cycle efficiency of steam turbine cycles, we proceed to the expansion of the fluid through several stages and with the intermediate reheating between the different turbine stages of the expansion. So, in order to be more accurate, as before, as for a simple kiln cycle, the vapor enters the higher stage, so high pressure turbine at high pressure and at the maximal temperature that can be admitted to this stage of turbine. So we have high pressure here before entering this high pressure turbine. Then the vapor is only partially expanded, so not directly to the low pressure, but to an intermediate pressure that we can call middle pressure, and point B will be this middle pressure after having done this partial expansion. So the expansion gave a decrease in the pressure, but also a decrease in temperature, and now it's still possible, before doing the second part of the expansion, to reheat the fluid. So the fluid will be sent back to a heat exchanger again in the vapor generator in order to reheat this fluid at middle pressure up to the maximal temperature that will be point C. And this is still at the middle pressure, because the pressure is not changing in the heat exchanger. And after that, at point C, the fluid will go again to a second stage of turbine that's called usually the low pressure turbine, in order to finish the expansion from the middle pressure to the low pressure that we will get at point D here at the outlet of this second stage of expansion. So here, for this example, I have chosen two stages of expansion, and in some facilities we can have up to 3 different stages of expansion with intermediate reheating, where the fluid is sent back to the vapor generator. Then the rest of the cycle is as before at point D. So when it's at low pressure, the fluid is completely condensed in the condenser, and then the liquid pump will increase the pressure from low pressure to the high pressure again. So if we look now at this on a TS diagram, we can now plot 3 different isobaric lines, respectively the high pressure, middle pressure and low pressure lines, and once again the maximum temperature that can be admitted to the turbine. Point A here is at high pressure and at this maximal temperature, point A, and then as usual the expansion is found using a working point that corresponds to the adiabatic reversible transformation, so that would be B is. Then the specific enthalpy of point B real for the real turbine using its isentropic efficiency is found, and it will be somewhere to the right, so that would be B real. Then so we have the expansion like this. Then the fluid is heated again at middle pressure up to the maximal temperature. So if it's not fully evaporated, then it will be fully evaporated and then heated up to the high temperature again at middle pressure, and this corresponds to point C. And then once again we have an expansion in a turbine, and so we can plot first here point D is for an adiabatic reversible expansion. Calculate real point D for the outlet of of the second stage of expansion, and point D real will be somewhere on this low pressure line, but at a higher specific entropy. And then the rest of the cycle is like before. Inside the condenser, the fluid at low pressure will be fully condensed to be at the outlet a saturated liquid, so point E is somewhere there, and then the pump will increase the pressure from the low pressure to the high pressure, and these points are almost merged. And the first heat exchanger in the vapor generator will increase first the temperature to saturation, then fully evaporate the liquid, and then superheat the vapor up to point A. So we can note that now the point D, so the outlet of the last stage of turbine, is moved further to the right. On my schematic we have point D that is even outside of the two-phase zone, but this is just schematic. If for example the saturation line is a bit more flat, then D could be still inside the two-phase zone, but anyway there will be less liquid and less condensation taking place in this cycle, where we have a stage expansion with intermediate reheating. So that's a presentation of the stage heat cycle with intermediate reheating.